Welcome back to the deep dive. I hope you're ready to roll up your sleeves today because we are tackling something that feels a bit like a philosophical crisis, but it's actually about code. We are staring into the abyss.
That sounds incredibly ominous for a tech discussion.
It is actually. We are staring into the abyss of software entropy. You know that specific feeling every developer knows it when you start a new project?
Oh, yeah.
It's day one, it's a green field, the code is clean, everything is organized, you know exactly where every file goes, it's pristine, it feels manageable.
That is the honeymoon phase of software development. Everything is possible, and no mistakes have been made yet.
Exactly, it's beautiful. But then, fast forward 2 years, maybe even just 6 months, and that beautiful green field has turned into what the industry technical term calls a big ball of mud.
Which is an actual technical term, by the way. It was formalized in the late 90s.
It's such a perfect visual. Tangled webs of interdependent classes, circular dependencies, logic that's so fragile that if you change the color of a button in the UI, somehow the database reporting job crashes 3 servers over.
Right. It's the butterfly effect, but for bad code. And while that sounds funny or maybe just frustrating for the developer trying to fix the bug, what we're really talking about here is a profound economic crisis.
Economic, that's a big word for spaghetti code.
It's accurate, though, because as that architectural integrity rots, the cost of change doesn't just go up linearly, it increases exponentially.
Exponential.
Your software asset, the thing you spent millions of dollars and thousands of hours building, it turns into a massive liability. You become afraid to touch it.
The fear of change. I've seen teams paralyzed by this. They stop releasing features because they're terrified they'll break the monolith.
Exactly. So today, we're talking about the antidote. We're doing a deep dive into clean architecture.
Which is really the study of how to build systems that can survive the test of time.
And not just survive, but thrive. The goal is to keep that cost of change flat, even as the system grows.
We've got a massive stack of sources today. We are primarily focusing on the work consolidated by Robert C. Martin, known to the world as Uncle Bob, particularly his book Clean Architecture from 2012.
Right.
But we're not stopping there. We're pulling in the precursors, hexagonal architecture, onion architecture, and we're looking at modern real-world case studies from giants like Netflix, Uber, and Shopify.
The mission for this deep dive is to explore a very specific promise, the promise of independence.
Independence from what?
From everything. Independence from frameworks, from the database, from the UI, from the outside world. The goal is to build a system where the business logic is sovereign.
Sovereign. I like that word. It implies it rules supreme.
It does. It means your business rules, the things that actually make your company money, they shouldn't care if they're being displayed on a website, a mobile app, or command line interface. They shouldn't care if the data is stored in Oracle, MongoDB, or it's a simple text file.
Which sounds like a total utopia because in my experience, the database usually dictates absolutely everything.
And that is exactly the trap we need to unpack first. Before we get to the solution, the circles and the arrows, we have to understand why the traditional way of building software, the way almost everyone is taught in boot camps and universities, is fundamentally flawed.
Okay, let's unpack this database-driven trap because I feel like this is the default setting for 90% of developers. You get a spec, you open your IDE, and what's the first thing you do?
You design the database schema.
Right. You draw your tables, you define your foreign keys, you argue about normalization, and then, once that is set in stone, you build what we call a layered architecture or N-tier architecture.
Exactly.
Paint a picture of that for us.
Imagine a 3-layer cake. At the top, you've got the presentation layer, the UI.
Mm-hmm.
In the middle, you have the business logic layer. And at the bottom, the foundation, you have the data layer.
It sounds logical. The
Yeah.
user talks to the UI talks to the business talks to the data, gravity pulls everything down.
It does sound logical, and for simple applications, it works. But look at the dependencies. The business layer depends on the data layer.
Right.
And the data layer depends on the database. That means the database is the foundation of your entire architecture.
So if the foundation moves...
The whole house shakes. This is called schema rigidity. Let's walk through a scenario. Say the business comes to you and says, we need to split the name field into first name and last name for better marketing emails.
A classic, seemingly innocent request.
Right. In a database-driven architecture, that change starts at the bottom. You change the SQL schema. Now your data access object, your DAO or repository is broken, so you update that.
Okay.
Now your business logic that uses that data object is broken, so you update that. And finally, your UI is broken. The ripple effect goes all the way up the stack.
So the business logic, which is
It
which
does.
is supposed to be the core value, right? The sovereign ruler of the system. It's actually a slave to the way we decided to store the bits on the disk.
Precisely. It is held hostage by implementation details. You cannot test the business logic without the database being present, because the business logic is coupled to the database structures.
And it gets worse. We also have to talk about the framework lock-in trap.
Oh, the we are a rail shop or we are a spring boot shop mentality.
We've all been there. Just use the framework conventions.
Exactly. Frameworks are amazing tools. I want to be clear about that. They give you a massive boost in productivity at the start. You type a command and boom, you have a user authentication system. You have routing. You have an ORM.
But there's a catch.
The catch is that frameworks act like intrusive partners. They want to move in, change the drapes, and put their toothbrush in your bathroom. They force you to extend their classes.
Right. Your business logic ends up living inside a controller or an active record model.
And that is the kiss of death for longevity. Because frameworks change. They die. They release breaking updates. Remember when Angular switched from version 1 to version 2?
Oh, I have distinct trauma from that. It wasn't an upgrade. It was a completely different language.
Exactly. If your business logic was tightly coupled to Angular 1.0, you didn't just have to update your UI. You had to rewrite your application. You are married to the framework,
Yeah.
and divorce is incredibly expensive.
So clean architecture is essentially a prenup.
That is a fantastic analogy, yes. It's a way of organizing your code so that if you want to leave the framework or the database or the UI library, you can do it without losing your house. You keep your assets in a separate bank account.
Now, before Uncle Bob put the clean architecture stamp on this in 2012, there were others shouting about this, right? It didn't just appear out of thin air.
No, not at all. It's a synthesis, a consolidation of decades of wisdom. You just
Sure.
look at the evolutionary lineage. In 2005, you had Alistair Cockburn giving us hexagonal architecture, also known as ports and adapters.
Which is a very cool name.
It is, and it shifted the mental model entirely. Instead of top versus bottom layers like that N-tier cake we talked about, Cockburn visualized it as inside versus outside.
They're hexagon.
Right, the core logic is the inside.
Yeah.
Everything else, users, databases, test scripts, email servers, it's just the outside. And they're all treated the same. To the application, a human clicking a button and a test script running a function are identical. They're just inputs plugging into a port.
That flattens the playing field. The database isn't the foundation anymore. It's just another thing on the outside, like a printer.
Exactly. Then in 2008, Jeffrey Palermo gave us onion architecture. He took that inside-outside concept and added concentric layers. He was really, really rigorous about the direction of dependencies. He made it explicit that all coupling must flow toward the center.
And then Uncle Bob came in with screaming architecture.
I love this concept, the library test.
Yes. Imagine you walk into a library and pick up a blueprint for a building. You see a large open area, a kitchen in the back with industrial stoves, booths, a bar area. What is it?
It's a restaurant. Right. The architecture screams restaurant. You don't know if it's French or Italian or a burger joint, but you know the intent of the building. Now look at the top-level directory of your current software project. What do you see?
Usually, SRC, controllers, views, models, utils, config.
And what does that scream?
It screams MVC framework. It screams Rails or Spring or Django.
Exactly. It screams the name of the tool, not the intent of the system. Uncle Bob argues that if you are building a healthcare system, your top-level structure should contain folders like patient, billing, diagnosis, scheduling. The architecture should scream the business domain, not the technology stack.
That makes so much sense, yet it's so rarely done. Okay, so let's get into the anatomy of the solution. We have this mental image of the concentric circles. That's the logo of clean architecture, basically.
The map.
Walk us through this map. We have 4 circles. What is the golden rule that governs them?
The dependency rule. It is the single most important takeaway from this entire deep dive. Source code dependencies must point only inward.
Only inward, toward the center.
Towards higher level policies. Nothing in an inner circle can know anything about something in an outer circle. The center circle is the most abstract, the most stable. The outer circles are concrete and volatile.
So let's start at the very center. Layer 1, the entities.
These are the universal truths of your business. If you are building a banking system, your entities are things like loan, interest rate, customer. These concepts exist whether you have a computer system or not. If you were running the bank with paper and pencil, you would still have loans and customers.
Now, I have to play the skeptic here. In a lot of code bases I've seen, a customer is just a class with a bunch of data fields. Name, address, ID. And then there are getters and setters. That's it.
That is what we call an anemic domain model. It is a massive anti-pattern in clean architecture. It's basically just a data structure. It holds data, but it has no soul,
No soul.
no behavior. In clean architecture, entities must be rich domain models. They shouldn't just hold data. They should contain the behavior and the rules associated with that data.
Give me an example of the difference.
Okay. In an anemic model, you might have a lone object that just has a balance field. And then somewhere else in a service class, you have a function called calculate interest, lone L. The data is separated from the logic.
Right, that's standard service layer style.
In a rich domain model, the lone entity itself has a method called calculate interest. The lone knows how to calculate its own interest. It protects its own invariance. You can't just set the balance to -1 million. The lone entity would throw an exception.
So the logic lives with the data.
Exactly. But here's the critical constraint that trips people up. These entities must be POJOs.
Plain old Java objects or
Right.
C# objects.
Right. They must have zero dependencies on frameworks. No database annotations. You know how in Java Spring or Hibernate, you often tag a class with @entity or @table to map it to the database?
Yeah, that's standard practice.
Forbidden in clean architecture.
Forbidden. That
It's-
feels inefficient.
It feels strict. But think about why. The moment you put that @table annotation on your domain entity, you have coupled your core business truth to a database implementation detail.
Ah,
If you want to switch from a SQL database to a NoSQL database, you have to go into your core entities and change the code.
you're dirtying the clean center.
Exactly. The entities should not know the database exists. They exist in a vacuum of pure business logic.
Okay, that is strict. So we have these pure, isolated entities in the center. What's the next ring out?
Layer 2. Use cases. Sometimes they're called interactors.
And what do?
They orchestrate. Entities have the core logic, the math, the validation rules, but use cases orchestrate the dance to achieve a specific user goal. For example, create order, or apply for loan, or generate report.
So the use case says, okay, fetch the customer, check if they are eligible using the entity logic, then create the loan and save it.
Correct. But here is the trick, and this is where the magic happens. The use case knows data needs to be saved, but it doesn't know how.
It knows it needs to be persisted, but it doesn't know if it's going to a hard drive or the cloud.
Right. The use case defines an interface. Let's call it loan repository. It defines a contract. I need something that can save a loan. But it does not implement it. The use case layer contains the interface definition, but the implementation is left for an outer layer.
This is dependency inversion.
Exactly. The use case owns the interface. The database adapter in the outer layer implements that interface. The dependency points inward. The database depends on the use case, not the other way around.
There is another strict rule about use cases regarding input and output that I found fascinating.
Yes. Use cases should not accept HTTP requests.
Wait, but usually a use case is triggered by a website? The user clicks submit on a form?
Usually, yes. But if your use case accepts an HTTP request object as a parameter, you have coupled your business logic to the web server. What if you want to trigger that same create order logic from a command line script, or a background timer, or a message queue?
I see. If the function expects an HTTP request, I'd have to mock a fake web request just to run the logic from the terminal. That's messy.
It's dirty. So instead, the use case accepts a simple request model, just a plain object, a DTO, data transfer object. Here is the customer ID and the amount, and it returns a simple response model. It creates a boundary.
So the use case is basically saying, I don't care where this data came from, just give me the raw numbers.
Exactly. It decouples the business rule, from the how, the delivery mechanism.
Okay, moving outward. Layer 3, interface adapters.
This is the bridge, the translator layer. Its entire purpose is to convert data from the format most convenient for the use cases and entities into the format most convenient for the external agencies like the database or the web.
This is where the presenters and controllers live.
Yes. Think about a web API. A controller receives an HTTP request. It extracts the data and turns it into that plain request model we just talked about. Then it passes that model to the use case.
So the controller is a plug-in to the use case.
Correct. And on the way back, the use case returns a result. The controller passes that result to a presenter. The presenter's job is to format it for the user. Maybe it turns a date object into a string like February 14th, 2026. Maybe it turns the data into JSON or HTML.
And this is also where the gateways live.
Right. Remember that loan repository interface the use case defined? The implementation list here,
Mm-hmm.
Squalone repository? This class knows how to talk to SQL. It takes the clean entity, converts it into a database row, and saves it.
I can hear the developers listening to this groaning right now because this sounds like a lot of copying.
It is. This is the cost of decoupling. You often end up with a user entity, a user DTO for the API, and user brow for the database. And you have to write mappers to copy data between them.
And that feels inefficient. Why am I creating 3 classes for the same user?
It feels tedious, but it prevents the inner circles from leaking out. If you just use the database row object in your UI and you change the column name in the database, your UI breaks. The mapping is the firewall that stops that fire from spreading.
It's insurance. You pay a premium in boilerplate code to avoid a catastrophic payout later.
That's a great way to put it, exactly.
Okay. And finally, layer 4, the outermost ring. Frameworks and drivers.
The details.
The database is a detail.
In the philosophy of clean architecture, yes. The database is just a mechanism for storing bits. The web is just a delivery mechanism. The architecture allows you to delay the decision of which database to use until late in the project.
Or swap it out completely.
Or swap it out. This layer contains the glue code. It connects your clean architecture to the dirty real world. You want to keep this layer as thin as possible because it is the hardest to test.
So we've built this fortress, but how do we actually rate the code? Let's talk about implementation and the principles behind it. We mentioned solid principles earlier.
Clean architecture is essentially the solid principles applied at the architectural scale.
Let's break that down. SRP, single responsibility principle. Usually we think of this as a function should do one thing.
That's the micro view. At the architectural level, it means gather together things that change for the same reason. If a change to the UI, like moving a button or changing a color, forces you to recompile your business rules, you have violated the SRP. The business rules shouldn't care about the UI. They change for different reasons.
The CEO changes the business rules, the designer changes the UI. They are different actors.
Exactly. Separate the actors, separate the code.
And DIP, dependency inversion. We touched on this, but let's hammer it home.
It's the primary mechanism. Traditionally, high-level modules, the business, depend on low-level modules, the database. DIP flips it. Both depend on abstractions. And crucially, the high-level module owns the abstraction.
This is a subtle but powerful point. The interface loan repository is defined in the use case layer, not the database layer.
Correct. This gives the business logic the power. It dictates what it needs, and the outside world must conform to it.
Now, different languages handle this differently. We've got listeners using Java, C#, TypeScript, Go. Let's do a quick tour of the nuances. Java and Spring.
The biggest battle in Java is fighting the framework. Spring really wants you to put logic in services and use JPA entities everywhere. It encourages the anemic model.
Right.
To do clean architecture in Java effectively, you really need to use multi-module projects like Maven or Gradle modules to physically enforce the boundaries.
So create a module called core domain that strictly has no dependencies on Spring?
Yes. If you try to import a Spring library into that module, the build fails. It's physical enforcement. If you rely on discipline alone, you will fail. Java developers love their annotations, so this takes real restraint.
What about .NET and C#?
.NET has a very strong community around this. They often use a library called Mediator.
Mediator, like MEDIATR.
Exactly. It helps implement the command query responsibility segregation, or CQRS, pattern within the use case layer. Instead of injecting a service into a controller, the controller sends a command object.
Okay.
Mediar reps the command to a handler in the application layer. It completely decouples the controller from the logic. The controller doesn't even know which class handles the request.
That sounds incredibly clean. It's like throwing a letter in a mailbox. You don't know who carries it, you just know it gets there.
Exactly. It's a really elegant pattern.
What about the JavaScript world? TypeScript, Node.js.
A bit trickier because of the dynamic nature. Interfaces in TypeScript vanish at runtime. There are compile time artifacts only. So dependency injection isn't as automatic as in Java or C#. You often need a DI container like in Versify.js or Nest.js to wire everything up.
But the principles hold.
Absolutely. You define interfaces for your repositories. You just have to be a bit more deliberate about binding the implementation to the interface at runtime.
And Golang.
Go is interesting. This standard Go project layout doesn't always align with clean architecture. Go developers often prefer packaging by feature like a billing package that has everything in it. But you can still apply the principles. A big tip for Go is using the internal directory.
What does that do?
In Go, if you put code in a folder named internal, it cannot be imported by any code outside of that project tree. It's a compiler-enforced way to hide your domain logic implementation details and force people to use the public API you defined.
Ah, so it's a way to enforce the boundaries.
It's a great way to simulate the encapsulation you get in Java, but using the file system structure.
Let's talk about testing, because one of the big promises here is testability.
It's not just about having tests, it's about the speed of tests.
Mm.
In a traditional architecture, if you want to test a business rule, you often have to spin up the database, maybe even the web server.
Integration tests, they're slow.
They take seconds or minutes. And if you have thousands of them, your build takes an hour. And when the build takes an hour, developers stop running tests.
And then bugs slip in.
In clean architecture, because your use cases and entities have zero dependencies on the database or the web, you can write unit tests that run in milliseconds.
You just mock the repository.
You mock the repository. You pass in a fake customer. You assert the result. You can run thousands of these tests in the time it takes to boot up a Spring context once. This creates the testing pyramid, a huge base of fast unit tests and a smaller layer of integration tests.
There's a pattern mentioned in the notes called the humble object. I love the name. What is it?
It's a strategy for the things that are hard to test, like a UI view or a database connector. You know how testing a UI is a nightmare? You have to use Selenium or Cypress, wait for elements to load.
It's fleeky. Tests fail because a button took 50 milliseconds too long to render.
Exactly. So the humble object pattern says, split the component into two. The humble object, which is the hard-to-test part, like the actual UI code that draws pixels, stays dumb. It has no logic. It just displays what it's told.
And the logic?
You move the logic into a presenter. The presenter calculates the string formatting, decides if the button is red or blue, decides if it's disabled. You test the presenter rigorously with unit tests, because it's just math and logic. You leave the humble object alone because it's so simple it basically can't break.
That's smart. You extract the brain from the body.
Yes. The body is the humble object. The brain is the presenter.
Now, we are getting into some advanced territory here. Distributed systems, microservices. How does clean architecture handle side effects? Like, when I create an order, I need to email the user and update the inventory service.
This is where we distinguish between domain events and integration events.
What's the difference?
A domain event is internal, order created. It happens inside your domain boundary. It's synchronous in memory. It updates other parts of the same transaction. For example, updating the customer's last order date.
Okay, that stays in the circle.
An integration event is for the outside world. It's a message you throw onto a bus like Kafka or RabbitMQ for other microservices to hear.
And
never leak your internal domain events to the outside world. If you do, you are coupling your internal domain logic to every other service in the company. If you change your domain event, you break the shipping service. You have to translate them.
But there's a danger here, the dual write problem. I save to the database and then I try to publish to Kafka. What if the database saves but Kafka fails?
Then your system is inconsistent. The inventory thinks the item is sold, but the shipping service never got the memo. The solution is the transactional outbox pattern.
How does that work?
Instead of publishing to Kafka directly, your use case saves the order entity and an outbox event record to the same database in the same transaction.
So it's atomic. Either both happen or neither.
Exactly. If the database transaction commits, the event is safely on disk. Then, a background worker, which is an infrastructure detail, totally outside the domain pulls that outbox table and pushes the messages to Kafka. It guarantees consistency without polluting your business logic with Kafka code.
I want to look at some real-world examples, because theory is great, but does this actually work at scale? Let's talk about Netflix.
Netflix is a poster child for hexagonal architecture. They have a massive content engineering domain. They have to ingest metadata from movie studios, manage assets, localized images, everything.
And the problem they faced.
Constant change. They needed to switch data sources. They went from a monolith JSON API to GraphQL. They switched databases from Cassandra to CockroachDB.
In a traditional system, that's a complete rewrite.
At Netflix, because their logic was isolated in interactors, their version of use cases, they literally just swapped the adapter layer. They changed the configuration. The business logic code remained untouched.
That's the dream. I'm changing the database becomes a configuration change, not a code rewrite.
And their testing speed. They could run 3,000 specs in 100 seconds because they mocked the adapters. That speed changes the culture of a team. It encourages experimentation.
What about Uber? They have a mobile app that is incredibly complex.
Uber found that standard clean architecture, specifically a version called Viper used in iOS, wasn't enough. It was too view-driven.
Meaning the structure of the code mirrored the screens on the phone?
Yes. But Uber's app has deep logical states that don't always have a screen, like geolocation tracking or matching algorithms running in the background, or the ride state machine.
Mm.
So they invented ribs, router, interactor, bilger.
Rides.
The key innovation is that the app is driven by a business logic tree, not a view tree. A component, which they call a riblet, can exist without a view. It's pure logic running in the background.
That's fascinating. It prioritizes the business operation over the pixels.
And then there's Shopify, a giant Ruby on Rails shop.
I always hear Shopify as the monolith that worked.
It is, but they ran into the ball of mud problem as they scaled. They had to decide, break it up into microservices, or fix the monolith.
They chose the modular monolith.
Right. They use a tool they built called Packwork. It enforces boundaries between modules within the monolith. So the inventory code cannot touch the billing database tables directly. It has to go through the public API.
So they basically used clean architecture principles to save their monolith.
And they handle 30 terabytes of data per minute. It proves you don't need microservices to get the benefits of decoupling. You just need discipline.
Discipline. That brings us to the critical analysis, because this all sounds great, but I imagine it's expensive.
It is. The cost of clean is real. First, there's the boilerplate. You are creating files for every layer. An entity file, a DTO file, a database model file, a mapper, an interface, an implementation.
If I'm just building a blog,
If you're building a simple blog or a CR-read, create, read, update, delete app, clean architecture is probably over-engineering.
it's like bringing a tank to a knife fight.
Exactly.
Yeah.
If your app is just moving data from a screen to a database with no logic in between, don't do this. You will hate it. It will feel like busy work.
And what about prototypes?
If you are a startup and you need to prove an idea in 3 weeks, and you might throw the code away, skip it. Speed is your priority. Clean architecture trains initial development speed for long-term sustainability.
It's an investment.
It is. Also, there's a cognitive load. Your developers need to understand dependency injection, polymorphism, abstract interfaces. It's not for junior teams without guidance.
Speaking of guidance, you can't just trust people to follow the rules, right? Entropy is relentless.
Code reviews are not enough. That's a quote I live by.
Yeah.
You need architecture enforcement.
Automated policing.
Yes. In Java, there is a tool called ArchUnit. In .NET, NetArchTest, there are dependency cruisers for JavaScript. You write unit tests that fail the build if someone breaks the rules.
So I can write a test that says, if a class is in the domain layer and it imports a class from the infrastructure layer, fail.
Exactly. You make the architecture part of the compile process. If you don't do this, I guarantee you, late on a Friday night, under a deadline, someone will bypass the layers to get a bug fixed. And that is how the rot begins.
Dirty architecture.
1 leak becomes 2. 2 becomes a stream. And soon the dam breaks.
There's a critique in the notes here about dependency injection itself. Some people say it's become an anti-pattern, that it makes code impossible to trace.
It's a valid critique if taken to the extreme. If you have injection madness, where everything is an interface and you have to dig through 5 layers of configuration to find out which code actually runs, that hurts readability.
Debugging hell. You press go to definition and it just takes you to an interface file.
It can be. But the counterargument is, would you rather have a hard-to-trace configuration or code that is literally impossible to change because everything is hard-coded together? It's a trade-off.
Let's start to wrap this up. We talked about the technical details, but I want to go back to the why. You mentioned an economic argument at the start.
Software is an investment. If you build it cheaply and quickly, but it becomes impossible to modify after a year, you have lost your investment. Clean architecture is an economic strategy to ensure that the cost of change remains flat as the project grows.
And there's this phrase in the text, the ultimate privilege.
The ability to change your mind.
Explain that.
As architects, we often have to make decisions with incomplete information. Which database could we use? Which framework is best? Clean architecture allows you to say, I don't know yet. You can build the core business value now and decide on the database later.
Right.
Or you can choose one now, and if you are wrong, you can change your mind later without rewriting the system.
That is powerful. It turns a one-way door decision into a two-way door.
And in a volatile tech world, that flexibility is the only true security.
I want to leave the listener with a final thought. We live in a world where AI is starting to write code, Copilot, ChatGPT. They are generating boilerplate by the gigabyte.
It's a flood of code.
Does clean architecture matter more or less in an AI world?
I would argue it matters significantly more. AI is great at generating logic, but it doesn't naturally understand boundaries. It will happily couple your UI to your DB if you ask it to. In a world of infinite cheap code generation, the role of the human becomes the gardener of boundaries.
We define the structure. The AI fills the bricks.
Exactly. If you don't have rigid architectural boundaries, the AI will just generate a big ball of mud faster than any human ever could. Architectural structure might be the only thing that keeps the chaos at bay.
A sobering thought to end on. Boundaries are freedom.
Structure is sovereign.
Thanks for diving deep with us. We'll see you next time.